In this lecture, we're going to talk about measurement. So let's do an overview. So the context is systems in operation, and operational data is being gathered. And the question is, why are you gathering this data? And the answer is there are three purposes for gathering the data. One is to generate alerts. So measurements are used to generate an alert. An alert indicates a serious problem with a system in operation, and it's sent to first responder, and first responder has to do something with the alert. It's also used for forensics. So when a problem has occurred, it must be identified, and that could be during the response to an alert, or it could be offline after things are done. And so logs are collected by the system. That's one of the types of measurements. And those logs are in response to events, and they're used to identify the problem and the characteristics of the problem. Helps in debugging. And then also you gather data to understand the performance of the system, understanding the end-to-end data of the system in response to requests, shows where the system spends time, identifies bottlenecks, allows you to redesign or restructure things to reduce the bottlenecks. And there's a basic architecture for measurement. So you're collecting information from a variety of locations. Talk about that in a minute. But then it all gets moved into a back-end database. And so the back-end database is typically time series, and that's where the alerts and the analysis happens. So what are the sources of measurement? Come from two sources. One is the infrastructure collects utilization. And the second case, the logs are produced by a server. So a service produces logs, and that's some of the information that's sent to the back end. And so in both cases, there's a service that is specific to the implementation of the back end. So common backends are Splunk or Logstash. And if you're using Splunk, there's a backend, a Splunk specific backend service. If you're using Logstash, there's a Logstash specific backend service, depending on whether you're collecting utilization or logs. And it gathers the information, it reformats it for the backend, and it sends it over the network to the backend. So one of the trade-offs is how much communication bandwidth is used for measurement. And then the back end will send an alert. And that alert is based on a collection of rules. And they're similar to auto-scaling rules. It also displays a dashboard that allows an analyst to quickly determine whether there's a problem. And it supports various types of analysis of the data collected. So here's an example of a dashboard. It's got pie charts. It's got red, orange, and green displays to tell you whether something is operating appropriately or whether there's a problem brewing or whether the problem actually has occurred. Has pie charts. It's got all kinds of graphical information to let you look at it and decide if how your system is operating. There's a problem in terms of time. In a distributed system, clocks, well, in general, in any computer, clocks drift. And that's around 1 second every 12 days, which doesn't sound like a lot, but when you work it out, that's in the order of milliseconds difference. And clock measurements based on a single computer will be accurate because on a single computer, the measurements have drifted together. But measurements across multiple computers cannot be used to reliably determine latency or sequence of events. So the sequence of events is important when you're debugging something, right? You have a problem, you say, okay, this happened, and then this happened, and then this happened, and oops, that doesn't seem right. latency, you tend to measure latency from the same computer. So if you send a request, then latency is going to be the time it takes to get that request back. If you're on a single service, then latency is the time between you receiving a request and responding to that request. And again, that's on the same computer, so those measurements tend to be reasonably accurate. But if you try and do that across computers, then you're going to end up having problems because of clock drift. And so one way of dealing with this is to use something called the network time protocol. So that coordinates all the clocks on the computers on a particular network. And they get an absolute time reading from the national, I guess it's the Naval Observatory, and distribute it to the computers on the network. And that's accurate to a millisecond on a local network, and it's 10 milliseconds on a public network. Now, if you look at how long it takes to do memory accesses are in the order of nanoseconds. So this is the notion that the clock is wrong uh, is going to disturb the measurements that you take. And so there are things called vector clocks, which are software constructs that enable you to have more accurate sequence readings. And we'll talk about tracing in a minute, but that uses request IDs to identify sequence. And that's another technique for sequence, telling you what the sequence of events are. Now, GPS time is accurate to about 100 nanoseconds, which is much better than the network time protocol, but you have to have access to the satellite in order to get GPS time. There's also atomic clocks, so if you're Google or Netflix or Amazon, then you synchronize things across the world with atomic clocks, but that's expensive for most people. So some, again, offline discussion questions. What are some specific functions a backend database provides? And you can look at examples. Again, I mentioned Splunk or Logstash to see the kinds of things they did. And then, given that clocks drift, how do you compute the time difference between your laptop and your telephone and your smartphone? So now let's talk about logs. So a log is generated by a service in response to some event. It could be an entry and exit into that service. It could be an error detection. And logs are used for forensic purposes, that is, finding the source of a problem. And the contents of a log are typically a timestamp, some identifying information, the reason for the entry, and then variable values. So if you record a log entry on entry to a service, and then and the values of the variables, and then you record on exit from that service, values that are returned back, you can have data to tell you whether the service is operating correctly or not. And here's a sample log from Windows. Probably can't read that, but the message is there's a lot of information in there, and it's an example of what I just talked about. And now you have to move the log files to the back end. So there's a picture. On your computer, there is an agent for the back end, and the agent will periodically, the logs are stored in known locations. It depends on the operating system. But if you have a service running on a Linux platform, then there is a separate /log, I think, maybe /var/log. I don't remember. But there's a separate directory where the logs are kept. And so your log agent knows this directory. It's specific to the back end, and it's specific to the operating system that you have. And it sends the logs periodically to the back end. Now, logs get to be very voluminous, And so the agent may periodically clean things up so that it doesn't get too full. It doesn't do that all the time, but it may do that periodically. So a couple of discussion questions. How does the service decide to generate a log entry? So I mentioned entry and exit. What else would cause the service to generate a log entry? And if the timing is inaccurate across computers, why did you put a timestamp in your log? That's another discussion question. So let's move on to metrics. So metrics measure utilization. So logs measure events. Something happened. This is the clock time. Utilization says my computer was 80%, the CPU on my computer was 80% active over this time period. And so you need to know the time period. It doesn't make any sense to say that at this particular time my CPU is busy because it's always busy at one point or another. You want to know how busy it is so that you can decide whether it's overloaded or whether to shut that instance down. And so that's a time period. Over a minute, it was I had 80% utilization. Over 5 minutes, I had 30% utilization, those kind of numbers. And the other resources measured are IO requests. And these are collected automatically by the infrastructure. So if you have something in the cloud, there is a automatic collection of this information. Again, there's a back-end process specific to that cloud provider and the back-end that will take that information and store it in the back-end database. So utilization, again, has the form value time period. And this is what I said about knowing that something is busy at an instant doesn't tell you anything. It's over a time period. And so how does the infrastructure do this? Well, it samples it every once in a while. It will ask the CPU, are you busy? And if it gets a yes, then it marks it, and then it can get a no, and then it keeps track. Another way of doing it is to have the operating system collect utilization information. The operating system knows when its processor is busy and when it's idle, and it can aggregate that. And so between the two of them, you can get utilization information. So again, a couple of discussion questions. Look at AWS CloudWatch, okay, or the equivalent from your cloud provider, and see how the information can be ingested by Logstash. So how do Logstash specifically and CloudWatch interact, or your cloud provider? How do you determine the correct time interval to collect utilization information? Okay, again, it's a trade-off. So you need to think about what are the issues. And now let's talk about tracing. So logs show a single event. Something happened at this time. And that's of interest, but you also want to know what's the end-to-end sequence of events. And that's what traces give you. So a request is assigned a request ID. So that part of the log information that you save, so that request ID is passed on every time to a server. And when that service makes a request to dependent services, it passes the request ID. And those are recorded in the logs. And then if you look at the Windows example that I showed you a minute ago, there's something called the event ID. Okay, same thing. And the request ID is passed, that's what I said. And now you get a request sequence, almost. And request IDs are saved in the logs, in the entries of a service. And a sequence is a subsequence of a request is called a span. So why did I say almost when I say gives a request service? Because it may be that one service calls multiple services, so it has multiple dependencies and it operates them in parallel. And so you need to have a mechanism to take the request ID and determine which branch of the tree that it's operating on. And there are such mechanisms. So here's an example of a span. Okay. And if you look at it, you can see that a certain amount of information was done in microservice, or time was spent in microservice 1. Other time was spent in microservice 2. Of the time that was spent in microservice 1, there's a specific function that was calculated. So that gives you more information, and you can look at that and say, oh, I'm spending an awful lot of time in one microservice or another. And so the request ID can also be used to identify the context of the request. It can be used to actually control things as opposed to just giving you information. And the context can be used for routing. You want to send things to A or B instances or canary instances. We'll talk about what those are, but there are specialized purposes, instances that have specialized purposes, variants of other instances. And you may want to route it to that, and you can use the context to control that. It can do system identification in terms of a family of systems. So you have a collection of systems, all of which might use a particular service, and by including the context as this comes from this family, you get more information about how the systems interact. Again, the purpose of a trace is to try and get more overall information as opposed to the specific information from logs. You might prioritize traffic. Use the context to say this message should be processed before other messages. So a couple discussion questions. What are different methods available to an analyst to determine performance issues? Okay, said one reason for getting measurements is to look at performance and see what can be improved. How do you do that? And how would you use context to support canary testing? Okay, well, we haven't talked about canary testing, so that's a little bit irrelevant. And that's what we're going to say about measurements. It comes back when we get to DevOps and talk about incidents.